All right, it's Thursday at 4:20 p.m. Eastern. That means it's time for Office Hour, your source for free cannabis cultivation education. My name is Keisha. I'm going to be your co-moderator today, and I don't do it alone. What's up, Mandy?
Hey, Keisha. Oh my gosh, how are you? Things are good over here. Yeah, we're signing on for episode 56. I'm psyched to see what we learned this week. We're going live over on YouTube, so if you're over there, make sure you send us your questions and I'll get those to the team. If you're active on social media, be sure you're following us on all the platforms. So we're on Instagram, TikTok, YouTube, LinkedIn, and also Social Club. But y'all sent us so many questions about growing this week and last week, so I'm going to go ahead and throw it back to you, Keisha.
Awesome. Thank you, Mandy. All right. If you're live with us here and you have a question, feel free to type it in the chat at any time. And if your question gets picked, we will either unmute you, have you unmute yourself, or we're going to ask for you. Seth and Jason are in the house today. How are you doing, guys?
I'm doing well.
Good. Yeah.
Yeah. Awesome. Yeah. We got a ton of questions last week that we weren't able to get through because we had an awesome grower. What's up, Dylan? Thank you again for coming on the show. So let's dig right in. This first one comes from Neokari Daniel. He wrote in, I've got a purge valve that dumps the lines out every time the pumps come on. Frequent pulsing seems to be a waste of nutrients. Should I just get rid of the purge valve?
The best way to do it just kind of depends on the frequency that you are doing your pulsing. Really the whole purpose of the purging nutrients in the line is one, to make sure you're not pushing hot fertigation onto your plants, and to make sure that the mix is stabilized. So when it's sitting in the line, usually we'll see that pH rise up a little bit. So it just depends on how long that nutrient is sitting in the line. One option might be to actually operate the purge valve off of a solenoid, and then you can start to control that. Maybe you are only purging the first irrigation of the day, kind of just depending on, how many irrigations you're hitting for the rest of that day. It may not need to be purged, and you could be probably wasting nutrients and some water. So that being said, a little bit maybe more control on there probably would be the best option, because first irrigation of the day, it is a great practice to purge out and make sure that you're not getting that stale solution, that warm stale solution get into the plants.
Yeah, I've been fortunate enough to try it both ways with electric solenoids and with pressure compensating valves. And honestly, the first thing to look at here is what we're doing is all drained to waste. So you're going to have to make a choice at some point. Like Jason said, you don't necessarily, best practice is to get the nutrient solution out of those lines in between irrigations, because we're not having hot nutrient soup sit on the tables and grow biofilm inside our lines, and also, again, have that pH rise issue. That being said, I personally think, as Jason said, the electronic solenoid is the best way to go. That way you can dump it when you need to and not when you don't.
Yeah.
Otherwise, at the end of the day, it probably also depends on how big your facility is. If we're talking a 400 square foot room with 3 or 4 zones in it, how much volume are you actually holding in those lines? Now if we're talking about a couple 100 feet of 2-inch pipe before we even get to the table manifold, it starts to add up to be quite a bit that we're wasting every time we purge that out. So those are things to, consider.
Fantastic, guys. Thank you so much for that. All right. YouTube is already popping. Mandy, I'm going to send it over to you.
Yeah. Thanks for the questions, everyone. Greg wrote in, how does Brix and sucrose percentage in solution affect EC?
In solution?
I think we might be talking about inside the plant. If we're talking about Brix,
usually that's going to be
in relation to EC. So if we've got a plant that is healthy, has all the fertilizer, nutrients, aka vitamins that it needs, plant essential elements, it's going to tend to have a higher Brix number because we're giving it everything it needs to produce more sugar. If we look at different areas of the plant, we can look at sugar concentration in the roots, the stem, the leaves, the buds. Typically, we're going to see, the plant is going to put more sugar into the roots if we have a higher salinity environment that those roots are in. Otherwise, when we're looking at Brix and sucrose levels, we can look at that as, performance indicators for certain phases of growth. So what we want to see is, like during stretch, for instance, we're trying to build structure, we want a lot of sugar production. We want a lot of sugar production during bulking. Ripening, we don't want a lot of sugar production. That's how we end up with dark green buds, black ash, basically. And not that that's necessarily the only factor, but that's the main one. I don't know if that's coming through the mic or not. We got some interesting noises in the building here.
Yeah. Okay, good.
Just got to explain Jason's weird face there for a second.
A little bit of construction in the room next door. So apologies if that's coming through.
Yeah. So I think Brix is a good thing to track, especially as we're getting further and further into cannabis production. However, that's something we're looking at as a quality indicator generally in, edible vegetable and fruit crops. So its application in cannabis, we can use it to evaluate, how well is our plant performing. Other than that, I'm probably not going to make any decisions based solely off of Brix. I'm going to be looking at environmental conditions and other factors. But like I said, it is another point in saying, hey, by week 3, I should hit a certain Brix level that I've observed over and over and over in a healthy plant. If I've seen one that looks not healthy, I'm going to test it. If it's low, okay, I messed something up. I missed it, but it's not going to directly tell us what went wrong or how to fix it.
Awesome. Thank you for that. And Greg, if you have any more context, please do send that in and I'll get that over to the guys. We had a question come in from Calicory, Maine. Hey, how's it going, you guys? Cultivar specific requirements aside, is it possible to drop humidity too early in late flower? Trying to control humidity for microbial reasons, but don't want to hurt terp and plant production.
So it's definitely a fine balance, and cultivar aside, that's going to be really hard because I've got some cultivars that are much more susceptible to molds and mildews. Knowing which ones those are in your room can help you target how much you actually need to drop your humidity. In general, we're recommending that drop in humidity typically to prevent molds and mildews. So if you have a very resistant strain, you can keep that humidity up a little bit higher and probably have a nice finished product.
Yeah. And, when we're looking at that balance, we don't want to have, like Jason said, we're dropping it purely, or not purely, but mostly for sanitation reasons. We don't want mold. But one interesting to me thing that I heard there was microbial reasons. Now, another thing to look at there is, since you said microbial and not fungal, what are we failing for? Like one thing I've definitely noticed is I've seen some people fail for, weirdly enough, E. coli. Why? Well, when your farm's next to a dairy, there might be some E. coli spores floating around in the air because you're next to a dairy, aka a feedlot. So sometimes looking at what we can do things preventative on the environmental side to avoid these. But when you say microbial, I would tend to look at sanitizing my HVAC, looking at my incoming air, what's going on there, looking at the incoming water, and really trying to chase out the source of that contamination, because botrytis, that's kind of hard. That's really ubiquitous in the environment. We can filter it out, but it's difficult. If you got fusarium or pythium or those are specifically root-borne diseases, but any other microbe in there, there's got to be a source for it. Typically, like I said, unless you are near big compost piles, you're not going to have E. coli floating around in the air in high enough concentrations to fail on your crop. But if your intake is next to a compost pile, you might. And it sounds like this is probably a logistical and practicality problem more than it is just an environmental issue.
So simple answer is yes. Keep it as high as you can without running into some of those mold and mildew issues. And when I say as high as you can, I mean within the recommendations.
Yeah. And, if you're going too high early on, one of the big dangers is, we're looking at keeping those stomata in a nice, our prime level of openness as much as we can during the bulking period. Every single day is production time. So if we start, raising that humidity more and more, we pass the point where those stomata are staying fully open and they're actually starting to close in response to real drought stress or heat stress. And as that happens, we're going to see reduced transpiration in production. So you want to ride that line and not go too far to where you lose bulking days, essentially, because we're closing stomata early. But we do want to slowly raise that VPD up in the end just to, again, avoid botrytis. And actually one that Jason and I ran into recently in a greenhouse, straight up aspergillus grown in your pots and buds. So stuff to look out for.
Awesome. Thank you guys for that. And Calicory, Maine did come back with, thank you, total Y and M count. And yes, mostly bud rot issues we're trying to avoid with these big buds. So awesome. That's it for over on YouTube for now. So I'm going to pass it over to you, Keisha.
Thanks, Mandy. Big fan of big buds over here. Woo! Good luck out there, Calicory. Keep us posted. All right. Dave Ray wrote in. When drying back generatively in early flower, I'm drying back a little too hard. So I'm going to need to add irrigation events other than my 2-hour window in the morning that I'm currently using. Should I just add events right after my current 2-hour window, or should I add events a little bit before lights go off? What do you guys think?
I mean, we can answer that, but typically what's going to be happening is either you're growing too big a plant for the size of substrate that you have. So you might think about that for the next run. As far as mitigating this run, I'm going to let you answer that one, Seth.
So with that generative steering, basically we really want to give as much time in between each irrigation as we possibly can. So when we're looking at like, okay, what can we do to mitigate the overdrying issue that we have, but not straight flip over into a vegetative steer, we're going to try to, still have our 2-hour P1 window and then wait until either 2 or 1 hours before lights off and just correct the amount we need. Now, if it's severely overdrying, like a lot of people encounter, say running a bigger plant in a 6x6x6, that might mean bringing it all the way back up to field capacity with multiple shots. However, one thing I find that work really well for me is if I am overdrying and I say, oh, I went 5% past where I wanted to yesterday, about an hour before lights off, I'm going to put on 5% shot just to correct that and not come in too low. And I'm going to try to, as best as I can, limit that to 1 shot. If I start to put on more shots, I'm starting to get into a vegetative P2 cycle, and that's what we want to avoid.
All right. A little bit of irrigation best practices there. Big fan of that. Thank you so much, guys. All right. Over to you, Mandy.
Yeah. Kevin wrote in, when drying at 60-60, I know 14 to 16 days is ideal, but what about the cure? What would the best method be for curing in 64-ounce jars?
In 64-ounce jars, so half-gallon jars. Make sure that you are burping them regularly. Obviously, there's not a lot of air. And even one good practice is if in the room that you have the jars in is maintain a humidity that isn't going to dry it out way too quickly when you do let fresh air in for the burp practices. Keep an eye on water activity. If you have equipment to do so, that's definitely going to make sure that, hey, we're not drying out or becoming more moist during the curing process.
Yeah, I couldn't agree with Jason more. Keep your environment that you're actually curing those in right at your 1660 as well, just so you can maintain that and you're not losing a bunch of moisture. Because with that cure, we want to hold it, in a moisture content range where we're still allowing some of that chlorophyll and other compounds in there to break down. That's part of the cure. We're getting rid of that hay taste, that grassy smell. We want everything to slowly mature. And if we dry it out too fast, it's not going to happen too slow. And if you're in the glass jars, I use those for years, honestly, at home and still use them at home because I'm not generally, growing too much. I'll just get little drop-in hygrometers that you can put in. You can drop them in 1 out of every 10 jars or 1 jar of each strain on your shelf and actually look right through the side of the jar and go, oh, that one's looking a little dry, and actually monitor that because ideally, if you got the environmental control in your room, you can burp those and leave the lids off for quite a while and actually get good air exchange. If your room's too dry, you'll start seeing the humidity in those jars go down, 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 down until you end up with some really crunchy buds. As far as time goes, I like to see at least 3 weeks usually from pulling it down off of the drying rack, going into curing, and then, we're looking at about 5 weeks after harvest usually, putting that bud in a package and on the shelf. I know some people like a tighter timeline on it. I've just found that if I give myself 5 weeks in a production cycle, that's ensuring that I've got a proper cure and I'm not putting any under or uncured bud out the door. If you got a premium brand built up, someone opens it and there's just no nose and it smells like hay, like they're not coming back as a customer.
Super important stuff to keep in mind. Sounds like you're on the right path though, Kevin. Let us know if you have any other questions about that. Holy Nodes wrote in also, what is the optimal way to hand feed cocoa daily? I'm in 3-gallon pots and typically feed every 3 days.
Ideally for hand watering, hand watering is definitely a challenge because you have a lot less control over what those water contents are doing. I mean, really, you're going to have to take a look at what the water content in EC is performing like in between irrigations. For a 3-gallon pot, it's going to depend on how much transpiration and evaporation is pulling the water from the pot in those 3 days. So, are you looking at still say 40% water content when you hit 3 days? Are you looking at 20% water content? That'll give you an idea of, hey, do I need to just decrease my irrigation sizes? Count a little bit less longer when you're hand watering. However you're doing that to try and stay consistent. And that's really the best way. And typically, that's one of the reasons that when people have migrated over towards more automated irrigations, we're irrigating every day and using a little bit smaller planter. It's typically because then we get more dry back cycles. We're exercising that plant to maximum potential.
Yeah. And, one thing I'd just like to outline, a lot of us, we've been at this long enough. You made the jump from bigger pots to a smaller prepackaged media. Even in like I used to grow in 3.5 gallon pots quite a bit. They're great. One thing though, is that plant to pot size is still crucial because we don't want to be going 3 days without an irrigation. If we can go that long, that probably means that plant's, a fair bit undersized for the media. And at that point we risk, having anaerobic conditions in the root zone. So if you can go 3 days right now, you might be running into, high humidity in the room, not giving you enough transpiration, a small plant, potentially, especially if you've been doing a lot of 3-day gaps, some root rot, anaerobic environment in the root zone. So really, if you are going to hand water in cocoa, people still have had great luck using 1.5, 2 gallon bags. You hit it once in the morning and then go generative. If you happen to be there in the afternoon and you're hand watering again, trying to get some P2s on is great, but hand watering always kind of comes back to practicality, right? I know in the past when I have to drag a hose around and water 800 to 1,500 plants in a greenhouse, guess what? By the time I get done with the first round with the hose, it's almost lunchtime. So put everything away, fill my res, and if the plants are big enough, come back and do the P2s that I can. But you want to make sure logistically that you're never going to back yourself into a corner where you can't be there to water when you need to, or you're massively overwatering and rotting out your plant's roots.
Thank you guys for that. We had one more question come in over on YouTube. Greg had a little bit more clarification. I meant more like backstrap and irrigation solution, similar to some of the cleanse and flush products. Can you use sucrose to raise EC in place of newts?
Theoretically, yeah, but I would venture to say that you're going to get potentially mold and a lot of other things you don't want growing in your root zone because you're just dumping straight sugar in there.
It's like the old days of using Terpinator.
Oh, yeah. Yeah. I suppose I don't see, I guess the biggest not benefits, but side effects of those products I see typically are biofilm in the line and plugged emitters as a result of, microbial buildup in my irrigation lines.
Awesome. Thanks for that. That's it for over on YouTube for now. So I'm going to pass it back to Keisha.
Ooh, thank you, Mandy. All right. David posted a question. And David, if you want to unmute yourself to speak to it, feel free, but I'll go ahead and ask. He wrote, is it okay to long-term store dry matter in Ziploc bags? I think I know the answer to that, but let me toss it to the experts.
Depends what those Ziploc bags are in. If they're in an environment that maintains, quality, if you are at the humidity that your water activity of your plants is, or your dry matter, is in that room, then it's probably okay. Ziplocs are going to be slightly permeable to some degree, and obviously make sure that you're storing it in a dark place. Probably other practices might be a little bit better, especially on a commercial scale. But obviously at home, you're doing what you can with what you have.
Yeah. On a commercial level, we see a lot of people use things like nylon or polyester turkey bags. The permeability of the plastic is the real problem with the Ziploc baggie. We can all, provided you know how to actually close the top, which most people do, that permeability is going to lead to oxidation in the bud. So like Jason said, you want to know where you're storing it. Now, If we go back and you throw a pound of weed in a gallon bag or half pound, whatever you can stuff in there, depending how small your buds are, in the freezer, we're probably going to end up with some freezer burn because that's a pretty permeable surface. Now, if I put that inside of a stainless steel container and did a nitrogen or CO2 purge, removed all the oxygen from the container, it's probably going to be fine inside that bag because if there was any exchange, I'm not pulling oxygen in. So, short story long, switch to glass.
Yes, that part I knew. Everything else you said, I was like, what? I had no idea.
Yeah, and that's something to think about too on a commercial level, right back to like when we were talking about curing. If I've got enough resources, right? Like if the studio we're sitting in was dedicated to only my finished product storage, I'm going to dedicate some HVAC resources to make sure that that room is holding exactly where I want it to all the time. And that's why a lot of the, if you look on Instagram and stuff, you'll see, oh, there's 5 pounds in a turkey bag, 10 pounds in a big turkey bag, whatever. That's how they get away with that, is maintaining the overall storage environment. And then also looking at things like, hey, do we need, pretty good air filtration in here just to make sure we don't have any spores floating around, really treating it on that next level for storage, not only inside the container, but even in not opening that door very much throughout the day.
David, I see you've unmuted yourself. You have anything you want to add to that?
Yeah, question. Thanks for the info. I'm a novice, so sorry about the
no worries.
But is there a benefit to storing in nitrogen in the glass? Because I actually have nitrogen available very easily.
Yeah,
it's ideal.
Mm-hmm. Yeah. There's actually a few companies in Washington and other places I've seen that utilize nitrogen packaging for their grams and eighths. It can be a little underwhelming because, the nitrogen effect is gone right after that first but it does seem to have a huge effect, I've noticed, on preserving terpenes and then also not getting what did someone call it recently I was talking to? Like the grandma's weed effect. Like when your grandma's had that same bag of weed for 30 years and it looks and doesn't really smell just the way you'd expect it to look when I say that.
Yeah, I'm trying to preserve it to the point where I can turn it into oil. I've done a test sample of the material, and I want to send it out and get my CBD and THC readings off of that. But I don't want to process the stuff until I get that information back, which could be a couple of weeks. So I have like a fair amount that I want to store. And like I said, I'm a novice and I don't know the best way to do that.
I'm not sure how you're planning on extracting it, but I'm a huge fan of fresh frozen if I know I'm going to go to extraction anyways, because then I'm just sealing it in freezer bags and throwing it right in the freezer until extraction and not having to worry about quite as much issues.
I was doing the isopropyl solvent extraction.
Gotcha. For sure. And you can still do that with fresh frozen. But yeah, if you have access to nitrogen and you're already past the cure, nitrogen sealing it in, half-gallon jars, just like Jason was talking about earlier, is a pretty solid way to keep your bud well preserved. And darkness. That's a big one. The old days of getting the brickweed. It's like, oh man, it's all brown and stuff. It didn't look that bad until they dried it on a rock under the sun for a week. And light destroys THC. So there you go.
Awesome. Thank you so much. Great question, David. Great conversation. All right, Mandy, over to you and YouTube.
Yeah, I love this. I'm taking notes over here, you guys. Back to Kevin's question about curing in 64-ounce jars. He says, thanks for answering the previous question. And what's your opinion on humidity packs? Would you add them in the jars to keep the jars at a certain percentage, let's say 62%, even though they haven't gotten below 62%, or would that affect the curing process?
I've had good luck with humidity packs, especially on the small scale. If you are dealing with 50 or 100 half-gallon jars, then you might look to a more holistic approach where you're controlling the humidity of the room rather than localized humidity in each jar. That being said, it's a pretty simple solution that I have personally found fairly effective.
Yeah, I use them all the time curing at home just because right back to what Jason just said. At home, it's great. I don't have, a huge amount. I don't have 50 or 100 jars I'm typically going after. I might have, 10 or 20 off a small harvest. Well, okay. I'm not going to put a humidifier and a whole control system in the closet where I'm keeping those jars. So therefore I do my burp. I got those in there. I use 2-way humidity packs. So that gives me a little padding either way, keeps me from, over drying or it getting a little bit too moist in there. So go for it. They're a great idea. And you know what I found? They actually last a little while too. As long as you don't put them in there when it's too wet, you'll get a few rounds out of using them. And long term, I've noticed they increase quality. We've even seen a few producers start to put those in their packaging just to make sure you get it at, optimum freshness.
We got to make you a cigar closet and use it for storage instead of cigars.
There we go. Yeah. No, I mean, that's what you'd want though, right? Is a big old cigar humidor basically to have that kind of perfect 60-60 or so.
I'm also a big fan of humidity packs for my little 4 jars of home grow.
Yeah, it really helps and it's easy. At the end of the day, how much, if you're not making a lot of money off your grow, I don't think people like us should try to sell you an Aqualab because that might be a little bit of overkill, but it's also if you're really trying to get that, boutique connoisseur cure, you probably need some sort of tool a little more than just the timed burp. There's a lot of variables inside your house or your building, wherever you're working in.
Yeah, I guess it really all depends on your setup and where you're at right now. Thank you guys for that. We did have a follow-up from Greg on his reason for his question on sucrose. He was worried about feeding too late in flower. Doesn't want to mess up his fade. So yeah, just a little bit more context on that. But I think that's the last question on YouTube for now. So I'll pass it back to you, Keisha.
Awesome. Thank you, Mandy. All right. This came in from Rooted NY. I'm assuming they're in New York. So love that. New market. I'm interested in these systems, assuming we were talking about AROYA here, and how they could work with horizontal mixes in raised beds. Would love to learn more about this.
So to start off with, I always like to talk about what we call the volume of influence. And that's basically how much of the substrate is the sensor actually reading. For the TEROS 12, it's about 1 liter of volume around the prongs. And so when we think about using in something like a Rockwool slab or 1 or 2 gallon coco, we're getting a pretty substantial sample of that substrate when we're measuring 1 liter of it. Becomes a little bit more difficult when we're in larger substrates, say 3 gallon, 5 gallon, 7 gallon. And this is where you really want to have that sensor installed in somewhere that is sampling the most average water content or EC of that substrate. And so a lot of times I have people kind of probe around in a larger substrate to understand here is how much striation I have in water content and or EC. And also think about where the bulk of your roots are, because we want to know what the roots are feeling. And that's why we're using this sensor in the substrate. So with, horizontal, horizontal, sorry. Vertical
layers.
Stack.
Just layers. That's all we're talking about.
Yeah. And the TEROS 12 is actually used out in field soils quite a bit. When we do field soil installations, a lot of times we'll go in at 6 inches, 12 inches, 18 inches. Depends on the type of crop that we're looking at. Some of the larger cannabis crops can have up to 2.5 or 3 foot deep of roots. In that case, we'd want to be at, say, 8 inches, maybe 2 feet, and maybe 2.5 feet. Typically, I like to have them evenly spaced out. And this is really kind of starting to introduce a lot more complexities than we have in something like Rockwool or coco, where it's a fairly predictable media. The composition of that substrate of the soil that you're working in is going to affect what those water content EC readings actually mean. When we look at the spectrum of matrix potential and cation exchange capacity, we have to start thinking about those for managing ECs and unknown composition of soils.
Yeah. And what I've found, number one, just the fact that the T12 was originally designed for field applications has made it incredibly useful in these bed situations. We can really, just like you're saying, map out what does our soil profile look like in terms of moisture content. When we're talking about a raised bed, if you got a 5 foot wide by 100 foot long bed, We'll want to look at sensor density, different depths, different areas, because man, it's hard to make a 100-foot long bed very level. So there's another dynamic we'll be dealing with there. When you're saying you're horizontally layered, do we have a well-drained base in there? So we're going to look at like, hey, our most wet point might actually be 6 inches off the bottom of the bed because we've got a gravel or a river rock layer to help with drainage. So there's a few things to look at in terms of that. But basically, if you're moving into a bed, you're kind of just taking, we've done a lot of work to bring greater soil science down into this small pot, right? When we're talking about working with cannabis production here, you're just blowing it back up from where we shrunk it down to. So you're going to be using that to look at moisture content, figuring out where you need to be looking at that. And then also, hey, you can't go pick your bed up. So this actually is one of the best types of technology you could use to evaluate, how wet it is in there. The biggest difference, we've really kind of dialed the use of volumetric water content as an output unit to relate how much water you're going to be putting on. That's the big thing that's going to change in terms of how to calculate your irrigation. It's not going to be the same way you'd calculate it off of like soil moisture potential, but we're not talking about a percent means exactly this many milliliters now just because of that volume of influence Jason was talking about.
That's great. Thank you guys for that overview. And actually I have a perfect segue into this next question. Someone wrote in on email. They want to know, what's the life expectancy of the TEROS 12?
I don't know that we have anything out there that describes the life expectancy. I have some at my house that are 5 years old at this point. I've been using since the beginning of AROYA. That thing is encapsulated. It's very durable. That surgical grade steel for the prongs really doesn't deteriorate at any calculatable value. So I would expect them to last 5 years easily, just from my personal experience. If they keep going from there, it's just frosting on the cake.
Yeah, I generally hear people talk about trying to buy them on a, at least outside of cannabis production, a historical, research setting, usually about a 6-year cycle. And that's not because they break. That's just because that's a funding cycle for them. They go, this is how long we expect these tools to last before I'm going to secure funding for more new tools because it's research.
That's also just happens to be about our new sensor release cycle as well. So.
Yep. And I'll say, guys, the only time there's only a few occasions I've seen the actual T12 sensor fail. Number one is using a hammer to install. That'll get them, unfortunately. Running over them after they've been installed loosely into the ground. Don't do that. And then,
rodents chewing on the cables.
That one. Yeah, the cables are soft spots, definitely. Mice will get you. Putting them in your barbecuer, that'll do it, But typically they're pretty tough.
Maintenance is key, in other words.
Or one of the other ones we see is people trying to adapt them to another system and not, consulting even like some of the meter guidelines about what kind of voltages and stuff it operates on. So if you overcurrent a T12 trying to get a reading off of it, you can melt the inside of it. But that's certainly something that's not unique to that hardware. That can happen anytime. I mean, let's go get an open sprinkler and try to open all the zones at once without putting relays on it. Like there's all kinds of electronics that you can overcurrent out there.
Word to that. All right, guys. Thank you so much. Mandy, over to you.
Thank you, Keisha. Calicory Maine came back with another question. Day 21, leaf pick skirting. Do you recommend lowering light intensity for 1 day following the pick or leave it alone? Do we risk stressing the plants too much or are we overthinking it?
My simple answer is that's overthinking it. When we actually look at the physiology of the plant, you might consider raising your light levels. We've decreased its ability to capture energy. And so since we've got less surface area, we're getting less photons to that plant. We really don't want it to slow down growing. And it's just kind of like when we go from an 18 hour cycle, veg cycle, to a 12-hour cycle, we need to up our light intensity to make sure that that plant is getting the energy it needs to continue photosynthesizing at the rate that it has.
Yeah, and something to look at too is like how hard you're deleafing and what a deleaf or a defoliation is versus a prune. and when you need to employ both of those, because, there's a lot of different styles in there. Typically on here, we talk about lollipopping early on to reduce some of that under canopy growth and not waste a bunch of time and make it difficult at your day 21 or end of stretch cleanup. But I mean, I've seen it done different ways. I've definitely seen don't really touch it till day 21 and then go clean up. And at that point, we're talking about an actual pruning, not a deleafing, where we're taking and cutting off full lower bud sites, not just taking fan leaves that aren't connected to a bud site.
Yeah, it's a really important balance, because if we over prune, we are doing some amount of stressing to the plant, and it's going to try and have regenerative growth, vegetative growth. When I say regenerative, it's trying to build stalks and stems again when we want it to be building up the bud sites that we've established through the generative crop steering. Obviously, if we don't de-leaf enough, sometimes we can have some larvier bud sites in the bottom of the plant that could have been pushed into nutrition for the larger colas that we'd like to get at for A buds.
Yeah. And, one thing I definitely have gone back and forth with a lot of people on is like, hey, I want to get, I'm stripping the top of the plant to try to get better light intensity down to these lower buds. That's a big thing that comes up. And, the reality is when we're talking about light intensity, every time we double distance, you lose 3/4 of your energy. So when we're looking at my zone of maximum production in terms of how deep in the canopy that light can get, sure, I can move away all the leaves that might catch the light going down lower if I want to, but no matter what, I'm losing energy the lower down I go. So shining a light on a bud farther away from the light is not going to lead to greater production compared to trying to put more buds up closer to the light.
Awesome. Thank you guys for that. And Calicore, Maine, yeah, it seems like it's just a balance, and we hope you guys find it. But that's it for over on YouTube for now. So back over to you, Keisha.
Thank you, Mandy. And just to clarify about the life expectancy of the TEROS 12, our team member, Rachel here, wrote, I used to work in the environmental repairs department before coming to AROYA. The T12 lasts easily 10 years in the field. So great information. Rachel, if you want to add anything to that, you're welcome to unmute. But
just a fun story. I've actually seen them go through a wildfire, and they completely survived that.
Well, there you go. So they can survive a wildfire, but not being run over. Sounds like.
No.
Still not recommended. We've had some wildfires in the grow rooms when the HPS bulbs pop, and that data is sometimes shocking.
That's one way to put it.
It's on fire.
Awesome, Rachel. Thank you so much for that clarification. YouTube is so on and popping. So Mandy, I'm sending it back to you.
Yeah. Wow. Growers are hardcore with those sensors out there. Oh my gosh. B-Town wrote in, I often hear about the 12% of end humidity in the buds when you buy them in the dispensary. How do big facilities do this in like 4 weeks? Turn down humidity while cure, or keep 60-60?
So yeah, 12%, I'm guessing that is moisture content. Really what we kind of help people do is start to use water activity to make sure that they are hitting those targets as fast as possible. I've seen realistically 10-day cures or 10-day dry cycles work out just fine. Comes down to airflow, humidity, and temperature control in those large facilities. And and obviously another advantage is getting to shelf on time. A lot of times, once this product is sitting at the dispensary or en route to a dispensary or in storage to be sold to a dispensary, it can lose some of its quality.
Yeah, and to your question is like, how do they accomplish that? Yes, it is maintaining that 60 and 60, but part of it is having the dehu capacity and the control granularity to maintain that. So like one thing we'll see is you bring a fresh crop into a dry room, boom, that humidity shoots way up. All right. So for the first 3 days, I need a lot of dehu capacity. And what I really need to be looking at is absolute humidity, not relative. Okay. How many grams of water or grams a milliliter do I need to pull out of this environment, this room, to get my relative humidity down to where I want it? Okay. Well, if I go overboard and I get 4 huge dehus that running, one of them or 2 of them can absolutely accomplish it take care of my first 3 or 4 days. Suddenly I don't have the granularity to step it down and remove smaller amounts of water from the air to maintain that 60-60. And now suddenly I'm overdriving it and I'm 5 days in at 40 and 65 or 70. And at that point, I've dried the outside of the bud too much. I've kind of locked in that crispiness, and it's going to be really hard to get that bud to cure properly without rehydrating it and getting, getting it right back in the zone.
Yeah. So in equipment side, I love automation and making sure that these systems are working. If you have some type of logging on the duty cycle of your dehumidifiers in your dry room, if those things are at 100% duty cycle, so they're continuously running, that means that we either have too much product in there or we don't have enough dehumidification capacity. That thing should be able to turn off just occasionally, within a few hours of loading the room.
Awesome. Thank you guys for that. I did want to take a quick pause and go over a poll that we had over on YouTube. So we asked, how many years have you been a grower? And the answers were 1 to 10 years or 10 plus years. And the answers, so we had 62% who have been growing under 10 years. And then we have legacy growers, so at 38%. So awesome. Thank you guys for letting us know how long you've been growing. We also had another question come in over on YouTube. So Calicory Main wants to know, question on leaf temp measurements. Can we log and plot this in AROYA? We are all LED. What's the danger or the warning zone for leaf temps? Sometimes seeing 80 to 83 Fahrenheit in the air temperature and sometimes up to 89 Fahrenheit leaf temp.
So, when we're talking about leaf temps, typically we want to see, in like early flower bulking, right around 78 to 82. 80 to 82 is generally scientifically where we see the best plant metabolism. That being said, there's a few factors here. Like with LEDs, a lot of times what we'll see is a lower leaf surface temp than the light, but that also depends on the ambient temp of the room. But I think you're right on there. And I believe we do have leaf surface temperature.
We don't have a specific one named for leaf surface temperature, but we do have a temperature of a sample, which you could easily use for leaf surface temperature. And just remember that that's the manual reading type that you're logging leaf surface temperature under.
Yeah. And that's a good point that you brought that up, because leaf surface temperature is what we really want to target when we're making our environmental changes. That's the microclimate that the plant actually lives in and transpires in. So when we're looking at, and that's why there's a lot of big differences between HPS and LED, right? How much does it heat up the surface of the plant, and why HVAC wise, we have to treat the two very differently. But that's what we're going to base, like I said, our temperature decisions, our humidity decisions, and ultimately, like when we're looking at air VPD, we all get used to looking at that because that's an easily measured value that we can log in time series data. When you first start dialing that VPD, the way we figure out what those air VPD values should be is by looking at leaf VPD and saying what air VPD, which is something I can measure consistently, what range can we keep it in where we also keep it desirable leaf surface VPD, which is that, millimeter above and around each stomata.
Awesome. Thanks for that. And thanks for all the questions over on YouTube, everyone. I think that's the last one that we have for now. So I'm going to pass it back to Keisha.
Cool. Thanks, Mandy. And yeah, welcome to the newer growers and the legacy growers alike. It's really good to have a good cross section of people visiting our little show here. All right. Ghost Grows wrote in, would you feel lowering water level during flower in a DWC to be a form of that irrigation control for crop steering?
It's a really cool question. So DWC being deep water culture, obviously a form of pure hydroponics where our roots are suspended in typically an oxygenated solution or fertigated solution, both. We see people do it in 5 gallons and stuff. My gut answer would be possibly, yeah. If we think about the amount of roots that are in water, that might be playing with that. What do you think, Seth?
So it's kind of tough. When you got plants that are developing a hydroponic solution, we actually see a little bit different root formation. We don't get nearly as long root hairs. So honestly, just lowering your level is probably not going to have nearly as much effect. Unless you're lowering it to the point where it's very, very low. But even if we look at like some of the first aeroponic setups, let's say, those were basically a shallow water culture with some squirters in there. The tip-seared roots were hanging down into a pool of water, even though it might have been more of a nutrient film or a shallow pool. It was still hanging in there. So I think, you might cause some different reactions. The bigger thing is how much air you're putting into that water. So do you have an air stone in that bucket with it, or are you just piping in oxygenated water and keeping the flow going? Because if you have an air stone in the bucket, you're going to get better growth than if you're just piping in oxygenated water, unless you're really pumping that water through at a high rate. The real steering in deep water culture that we typically see is purely EC influenced. We're raising and lowering that EC, adjusting the pH, and dealing with the nutrient load and osmotic pressure that we're putting on the plant. But dropping your res, depending on your ratio, you might be raising your AC. And I'm not sure what else you're doing. There could be a few factors here that all come together to produce some of the results you want.
I've worked with a couple of growers in aeroponics, not in DWC like this guy's talking, but they actually increased some of their spray off times to try and do some of this crop steering that we do traditionally in Rockwool and coco. And the reports from the field were that it was a functional way of controlling using aeroponics in their case, which I find quite fascinating.
Yeah, and it's tough too because, we, like Jason and I, focus almost exclusively on Rockwool, coco. We do some soilless stuff back to the beds, but when we're talking deep water culture and aeroponics, there's a huge technology component here. When Jason is saying like their off times that they're playing with, okay, can everyone doing aeroponics do that? Maybe not. There's different systems out there that wouldn't seal up well enough for you to do that. The root zone would dry out. If it's a well-designed system, you might have twice the amount of time that you could have, your sprayers off without actually causing root damage. So there's a few factors to look at there.
Great. Thank you. Gosh, there's so much to learn every episode. Deep water culture. I'll be looking that up after the end of this show. All right, Mandy, sending it over to you and YouTube.
Yeah, we got a lot of shout outs. Dr. J says, love the show. Thanks, Dr. J. We've seen you around a long time. Calicory Maine came back with a little bit of context. Thanks. Sometimes I worry in early flower and in stretch that we're too humid and the leaf temp rises. When we increase airflow or drop humidity, we can lower the leaf temp and the plants drink more. So, and then also we have some more questions rolling in. So Kevin wants to know, I hear people talking about light leaks when drying. Does ambient light from across the room affect the drying process?
I mean, it depends how much. It's, direct UV exposure is really what breaks down the THC in components. So, low amounts of lights may not be too big a deal. That being said, how much work is it to clean up your light leaks? That's probably how I would approach it.
Number one, UV. Where's your light leak coming from? Do you have a window to the outside, or is it a fluorescent light from the hallway? And if it's a fluorescent light from the hallway, tape up some paper over that window and the door,
And I did want to follow up on the response from Calicory, Maine. When their humidity was a little bit too high, like they were talking early in flower, they might not be hitting their target VPD, which means that our stomates are slightly more closed. We're not hitting optimal transpiration rates, and that's why your leaf surface temperature goes up. The more that we're transpiring, the more that the evaporation, the transpiration from the leaf surface is decreasing the temperature of the leaf. So if that transpiration goes down, it's absolutely expected to see the leaf surface temp go up a little bit.
Awesome. Thank you. And thanks for all the questions over there. I'm going to keep going down our list. Iron Armor wrote in, can you guys go over again how to apply absolute humidity readings to your grow room and dry room?
Sure. So let's just start off with explaining absolute humidity. Most people that aren't directly working in the HVAC industry are used to relative humidity, which is talking about how much water as a percent of how much water that air can hold at that temperature, right? So if our temperature goes up, our water holding capacity goes up as well in that air. Absolute humidity is actually a calculation of how many gallons of water are in a volume of air, right? And so these are nice calculations when we're looking at increasing HVAC systems or making HVAC changes to understand how much capacity we have to dehume from the room. Same thing with the drying room. If we're using absolute humidity and we can see, hey, when we turn our system off, our absolute humidity goes up at 2 gallons per hour, then we need to be able to have a dehume that can accommodate for slightly or somewhat more than that amount that the water is getting into the air. So rather than a percentage, it's actually a unit of measure of water in the air.
Yeah, what it does is, a lot of these dehues are rated in like how much they can pull out over a time period, right? So I can look and say, all right, I'm capable of pulling X amount of water in gallons, liters, quarts, whatever I want to use that manufacturer is specifying. But I say, okay, this is the rate it can pull it out. Right now, I have got X amount that I need to pull out of the room. I need to pull out 30%, or let's say 6 grams for every cubic meter I have of water. Well, I know 1 gram of water equals 1 milliliter. I just figure out the volume of my room, figure out how many milliliters of water I want to pull out, look at my liter rating and say, okay, over time, how many liters do I need to pull out in a day to achieve my goal? Then I can start dehue shopping and see if what I'm looking at is even close to reasonable, or if it's going to be way too much or not nearly enough. Because we've certainly seen it every which way when people are trying to size these. And it's tough because you've got, people like us that are out there helping people out that have developed a lot of this based on a certain situation that they've seen that's worked for them. They'll say like, hey, we need 20 liters of light. That's going to do it. And it's like, well, sometimes there's a lot of other calculations to take into account. And the other thing that I found out is when I was first learning about greenhouse design, operation, and how to calculate how much airflow is going through, just like a lot of other things in general big agriculture, we're looking at the smallest delta possible for economic means. So when it comes to cannabis, we're looking at much bigger deltas, a lot bigger differences in humidity variation, temperature. We're really running these grow facilities at a everyone uses the sports car analogy, but it really is like that. We're calculating things on a way wider difference and looking at parameters that traditionally we just didn't approach when growing spinach or ornamentals or something, because the profit margin wasn't there. We didn't have the impetus to need to do this.
You're growing tomatoes on steroids.
Yeah. And there's a lot of books on growing tomatoes, it turns out, and a lot of books on how to do it as cheaply as possible. And that's just not the kind of approach we are taking in cannabis.
So to go back, absolute humidity is temperature independent. So if we have 1 gallon, per cubic meter, and for absolute humidity, then at a specific temperature, that relative humidity would change, whereas the absolute humidity would still be 1 gallon per cubic liter.
Yeah, like a good thing to think about if you really want to see how much temperature affects that relative humidity is if you want to run a 65 degree overnight temp in your last 2 weeks of flower, to maintain the VPD that I want you at means you're going to be at about 43 to 45% relative humidity. And that sounds pretty low to a lot of us that are looking at humidity in a grow room,
Man, all about humidity. Thanks for that. We have a couple more questions that came in over on YouTube. JT wants to know, and this, we might have to give a really shortened answer for this, but can you explain the process of a leaf tissue analysis?
Like from the grower standpoint, you take a leaf sample and you send it into the lab and then they send you the results of it.
Typically, yeah. And then as a grower, if you are going to engage in leaf tissue analysis, your best bet is to get on a program with a lab, and you're going to be sending them weekly samples throughout different grow cycles with different strains and mapping out, just like we were talking about back to Brix, what we need to look for KPIs in a certain strain. So, if you're talking to someone who deals with tissue analysis a lot, they're definitely a good help on establishing benchmark goals for different nutrients in the plant. But with the variation we see in cannabis, there is no single golden standard for marks that you have to hit. We'll look at it and say, hey, we know that typically when we see plants below a certain ppm of calcium, we see these issues. But not all plants are going to behave the same way. So really what you're looking for is some of those key nitrogen, calcium, phosphorus, potassium benchmarks, and then some of your micros, just to make sure you've got adequate nutrition. And then if you do have one, a certain strain that's got some interesting properties, like every time you grow it, it just throws off way lower pH runoff or way higher. You can start mapping that out and then say, hey, when I see this problem, this is what it appears to be a deficiency in. Or more like, hey, if I take a leaf tissue analysis and it's this particular strain, I'm seeing this problem, I know that it's a nutritional problem and that this plant has very specific needs, and I can rule out certain other things such as pests and disease.
There we go. All about continuously improving. We had another question come in. Maynard wrote in, what EC would you recommend pre-soaking Rockwool cubes for germinating seeds?
I mean, it's going to depend a little bit on the cultivar's preference and what type of nutrients you're using. For germinating seeds, you're probably going to want to be a little bit low. I personally like to germinate seeds just in a humid, dark environment. And then once the taproot has split out, then I like to put them in the Rockwool. That's not necessarily at a scale. What do you think?
Usually about a 1.5. Make sure you got some CalMag, make sure you're pH'd. You don't want to get it too hot because you're not going to have a lot of uptake for quite a while. And even to that effect, when using really small starter cubes, especially, distilled or deionized water. Honestly, we're just trying to get that pot to pop. Once it's, very small, we want to get that into its next medium as soon as possible. We don't want that taproot hitting the bottom of the tray and then just wandering around. We want to time it so that's going out of our tiny Rockwool cube directly into a bigger media so we don't slow that taproot down.
Sweet. That was awesome. Thank you guys for all the knowledge you dropped today. And thanks to everyone over on YouTube for answering our questions and bringing yours. I think that's it that we can get to today. So I'm going to pass it back over to you, Keisha.
Awesome. Thank you, Mandy. I'm gonna do this question as our close. Bilbo, our good friend Bilbo, he's on the horn today, submitted this, and I love this question. We weren't able to get to it last week. What specific plant development stage is your favorite, its phase day range, and why?
The smoking stage.
Oh, same as me.
Post-production.
Oh, there we go. Technical. For me, probably one of the most favorite is a transition from veg to flower because it's the time that offers some of the most challenging decisions and also the ones that can offer the most opportunity for a high quality, high yielding plant. Making sure that I get that dry in on transplant and start to stack my ECs in the right time frame. Definitely exciting to see that plant morphology change.
I personally love watching bulking because I can see everything that happened up to that point, and then it's followed right by my next happiest or the most sad phase, and that's when I over bulk it and then mold everything out. So ripening is always I think everyone's least favorite phase, maybe. Visually, it's beautiful, but from the cultivator's standpoint, that's the scariest time for sure.
Bilbo, what's your favorite?
I'm not going to lie. I really like the one that was described, not the smoking one necessarily. I like the challenging phase going into flower where you realize that you have to take the work that you put down in veg and make sure that it's within an acceptable range, especially if you're growing something new or there's some outside influences.
Mm-hmm. That's the most dynamic part early on. The farther we get into any growth cycle, the less we can do to influence the outcome. So, day negative 28, let's say, that day of cut, that's just as important as that transition phase as everything else. So early on is where we actually do see a lot of that, the art part of it, the hand skill, the part that you have to learn, not be taught, I would say.
Preach.
Preach indeed. I love that question. Thank you, Bilbo. We have 2 more minutes. Let me squeeze one more in. Someone wrote in, what should I do if my field capacity and EC are continuing to rise on a generative steering? And they put water, but I don't know if that's what they meant.
Yeah, generative steering irrigation strategy. Well, EC, easy one. Usually when we're generative, we're allowing some amount of salts to build up, and that's why we call it generative stacking to some degrees. I like to call it stacking for two reasons. One, because we're stacking the nodes, trying to decrease node spacing and build out as many bud sites as possible, but also because visually when we're looking at the day-to-day EC in AROYA on those curves, the EC is gradually stepping up day by day because we're not resetting all the way back down to our input water content. As far as field capacity, usually we see that stay about the same or decrease a little bit. Off the top of my head, I don't have really easy things to point at that might explain that.
Typically, what I would say is, number one, make sure your initial hydration procedures are correct. Make sure you're all the way hydrated, because some weird things can happen even in cocoa, where we'll develop hydrophobic pockets that might start to hydrate later on after the block's been wet for a week or two. If
you get lucky.
Yeah, if you get lucky. And then, the other thing is too, if you're like, especially hand watering, or one thing I've run into lately is some of the holdover people out there still using octobubblers that haven't tried to neck them down as much as they can. Basically what's happening is channeling. So you're getting premature runoff. You're not actually hitting field capacity some of the time. So one thing you can really do is if you don't have any monitoring equipment, go get a hold of a Solus, and every time you hydrate a new batch of media, test it and see what your field capacity actually is, and then just regularly test it at the right before P1 and right after your P1s. And if you hit runoff, see, and then if you're playing around with your shot size and you notice, hey, like I'm getting runoff quicker during this phase, or when I try to put on a shot of this size, go test that and see if you've actually hit field capacity, because you're eventually going to find out that, like, hey, if I have a % per minute shot, I'm going to hit 8, 9, 10%, 10 minutes, and suddenly I'll get premature runoff. It's too big of a shot versus if I would have put on 2 5% shots and or 2, let's say 8% shots versus the 10, and I actually hit 16. Whereas if I put 2 10s on and only hit 14, that was too much too fast. So really, really make sure you've established what that field capacity actually is, because we should see it, like, especially in a cocoa pot. Like if you went clone into a 1.5 or a 2 gallon, rooted in and then flipped, we should see that field capacity actually go down a little bit as that pore space gets completely packed with roots.
Amazing. Thank you all so much for all of your questions. Before we sign off, let's give a shout out to the brands helping our experts keep their hat game on point. What are you guys wearing today?
I've got my Mills hat on. I like the blue color of it. It fits well.
Yeah.
I'm repping the Exotic Genetics hat. Some breeders up here in Washington that are continually putting out fire. Got to support them.
Right. Yes. Thank you for the hats. Thank you, Seth and Jason, for a fantastic conversation. Man, I learned a lot. Mandy, I couldn't do this without you. Thank you for being my partner in co-moderation, and producer Chris for holding it down behind the scenes. Thank you to everybody for joining us for this week's AROYA Office Hours. We do this every Thursday, and the best way to get answers from the experts is to join us live. To learn more about AROYA, click the link in the chat. That'll get you a demo with one of our experts. They'll tell you all about how AROYA can be used to improve your cultivation production process. As always, if there's a topic you'd like covered in a future office hour session, post questions anytime via the AROYA app. Feel free to drop us a note in the chat. Send us an email at support.aroya@metergroup.com. Send us a DM over Instagram and all the socials. We want to hear from you. We record every session, and we will email everyone in attendance a link to today's episode. It'll also live on the AROYA YouTube channel. Like, subscribe, and share while you're there. And if you find these conversations helpful, please do spread the word. Thanks, everybody. We'll see you next time. Bye.